right, we're going to continue on with momentum and add a little bit to it. So just to remind you about what momentum is just the measure of a motion of object. The object must be moving to have some momentum. We calculated it by taking the mass times the velocity. So that was our equation for momentum. We did a lab and we did practice problems last time. If you have not done those, I suggest going back and doing those so that you're not having trouble with the concepts we're going to go over today. We also talked about the total momentum in a system, and we wrote that equation. That total momentum was just the momentum of object 1 plus the momentum of object 2 plus the momentum of object 3, and so on and so forth, however many objects you have in your system. And we looked at that with the lab where you added the momentums of two different objects together to get a total momentum. All right, then today we're going to talk about impulse. Now, you did have an impulse question on two of them, actually, on your last set of practice problems, and it gave you an equation. So let's go ahead and talk about that equation. So impulse is just the change in momentum, okay? So if the momentum changes in some way, that is, if the object changes velocity, it has a change in momentum, and there were a couple questions over that on the last practice. Or if we have an outside force acting on the system, or a net force acting on the system over a time interval. So the general equation for impulse is J, so we represent impulse with a J, equals the force times the time interval. So J is impulse, F is force, and T is the time interval, okay? And the units for impulse, you really can use two different ones. You can either do a Newton times a second, since we're multiplying a force times time, or you can use the kilogram meters each second. And we're going to, in the next slide, look at how, why these units come out to be the same. So, impulse. We can actually figure out the impulse three different ways. So we just talked about one of them, and that's with the impulse equation, okay? Well, we have an equation for a net force, and we said it was mass times acceleration. We had an equation for acceleration, which was the change in velocity over the change in time. So I can actually substitute these into the impulse equation, where I get mass times acceleration, because that's my net force equation. Then instead of the A for acceleration, we're going to put in the equation for acceleration, which is over here, and then multiply that by time. Well, you can see that the time reduces. So another way to calculate impulse is by taking the mass times the change in velocity. So now we have shown two ways to calculate impulse. The third one is looking at this. Well, the change in momentum is going to be the momentum final minus the momentum initial. Remember, a change in anything is always the final minus the initial. Or we could say the mass times the final velocity minus the mass times the initial velocity. Well, I can factor out the mass, and I can say it's mass times the final velocity minus the initial velocity, which is the same as saying the mass times the change in velocity. So the third way to calculate impulse is by just doing the change in momentum. So we defined impulse as the change in momentum, and we can also write that as the force times time is equal to the mass times the change in velocity, using equation 1 and then the equation here for the change in momentum. So these are different ways that you can use the impulse equations and different ways that you can find impulse. So it's going to depend on what you're given in the problem. So this is one of those where it's really important that you look at what is given in the problem and what it's asking for, okay? All right, we're going to do a flow chart with some notes. So the three main concepts, we're going to do the first one here in a second. But we're going to fill in part of this flow chart today, namely just over here with the single item. So most of the practice today is going to be with a single item. So we're going to talk about that. The multiple we'll start talking about in the next class period. All right, so let's talk about this main concept number 1. All right, important concept number 1 is what we just talked about. So it is that an impulse causes a change in momentum. Ooh, I do not know what happened with my pencil right there. Sorry about that. So J is impulse, can equal force times time, but it can also equal the change in momentum, which can also equal the mass times the change in velocity. So again, it's just going to depend on what the problem asks you to solve for which part of the equation you're going to use or which strategy you're going to use. Okay, we're going to fill in part of our flow chart now. So the first thing when you start is you're going to want to look at how many objects do you have. So there's only two things that can happen. You have one object, that's what it means by single, or you have multiple, which is more than one. Oh, that was really sloppy. Sorry. More than one is the multiple. We'll be talking about the multiple more next week, other than just calculating the total momentum if you have more than one object in your system. Okay, so then if you have a single, what you want to ask first is there a change in the velocity or a force? I'm sorry, I cannot write that small to fit in the box. Okay, so is there a force or a change in velocity? If there is, then you're going to use the impulse equation of force times time, or you're going to use the mass times the change in velocity. Okay, it's just going to depend on what you're looking at. In general, the equation is the initial momentum plus the impulse is going to equal the final momentum. Okay, that's another way of writing just the general equation. All right, if there is no force or change in velocity, is the object moving? And by the way, you don't have to print this form out unless you want to. It is available on the page where this video is if you want to print it out. Otherwise, you can just draw it on a piece of notebook paper or colored paper. All right, so if the object is not moving, that means it has a velocity of 0, so it has a momentum equal to 0. So it has no momentum if it is not moving. If it is moving, then you just calculate the momentum. Using the equation we've been using so far, which is just mass times velocity. All right, that's it for the notes on this for today. Next time, we will go a little more in depth with talking about multiple objects and what happens in collisions and the other two important concepts for this unit. Okay, so we just gave you one right now, and that is the impulse causes a change in momentum, and we're going to practice with that equation today. So the practice problems for today look really similar to before. Remember that the little sigma thing, this summa, just means total momentum. Okay, just means to add them all up. And they did give the general equation over here that I gave you before. The initial momentum plus the change in momentum has to equal your total final momentum. Okay, so most of these are just plugging in the numbers, calculating it. We will post an answer key and a video going through some example problems. But if you have questions, just let me know and I'd be glad to help you out. Have a great rest of your day.